Given that root 2 is irrational, prove that 5 plus 3 root 2 is also irrational. Now, to begin with, let's just clarify what is meant by that term irrational. If a number is rational, this means that it can be expressed as a quotient or fraction, a over b, where a and b are both integers and b is not equal to 0. For a number to be irrational, it means that it cannot be expressed as a fraction in this way. To answer this question, we're going to use a method called proof by contradiction. So we're going to assume instead that 5 plus 3 root 2 is rational and therefore can be written as a fraction a over b. We want to show that this leads to a contradiction, and the contradiction that we're looking for is that root 2 is rational. As we know this to be false, this will mean that our original assumption is also false. So we begin with the assumption that 5 plus 3 root 2 is equal to some fraction a over b, and we're going to rearrange this to give an expression for root 2. The first step is to subtract 5 from each side, giving 3 root 2 is equal to a over b minus 5. Now a over b minus 5 can be combined if we think of 5 as 5b over b. So we have a over b minus 5b over b, and as the denominators of these two fractions are the same, we can subtract the numerators, and it simplifies to a minus 5b all over b. We have then 3 root 2 is equal to a minus 5b all over b, and the next step in rearranging to give an expression for root 2 is to divide both sides of this equation by 3. Dividing by 3 just leaves root 2 on the left of this equation, and the 3 joins the denominator on the right of the equation, so we have root 2 is equal to a minus 5b all over 3b. So we found our expression for root 2 in terms of a and b. Now here's where our contradiction comes in. If a and b are integers, which they were when we defined them at the start of the question, then a minus 5b and 3b are also integers. If we allow a minus 5b to be the integer p and 3b to be the integer q, then we've written root 2 as the fraction p over q. However, by our definition of a rational number, this would mean that root 2 is rational, which is a contradiction, as of course root 2 is irrational. So, by assuming that 5 plus 3 root 2 is a rational number, this led to a contradiction of the fact that root 2 is irrational. This means that our original assumption was false, and therefore 5 plus 3 root 2 is irrational.